Hello everyone, welcome to the lecture about sensors. To make things smart and connect the world, we need three types of abilities. Sensing, which is the ability to collect information. Computation, which is the ability to process information. Communication, which is the ability to exchange information. By far, we have covered communication and computation power. Today, we will be focusing on sensing ability. In today's lecture, we will learn what is a sensor, the types of sensors, and because we do not have enough time to cover all those types of sensors, we will be focusing on one example, the temperature sensor. In order to know how to provide sensing ability to electronic devices, let's first look at how we have sensing ability on human beings, that is how people collect information from the environment. In fact, we have lots of sense organs. For example, we have skin to detect touch, pressure, temperature. We have tongues to taste different flavors. We have eyes to see, we have ears to hear, and also we have nose to smell. Then the next question is, how can we build similar abilities to electronic devices? And we call them sensors. So what is a sensor? A sensor basically is a device that can measure or detect a real-world condition, for example, motion, heat, or light, and convert it or translate it into analog or digital representations or signals so that other devices or humans can understand them. There are different types of sensors. For example, we have vibration sensor to detect the motion. We have temperature sensor to measure temperatures. We have force sensor to detect pressure or pressing, and also we have LED sensors in those CCTV devices. Humidity sensor. Do you know that we even have humidity sensor in our mobile phone? In fact, iPhone has humidity sensors to make sure the device is working in a dry environment. Magnetic sensor make compass application available on our mobile phones, and the accelerometer make it possible for the mobile phone to detect motion or shaking. I'm sure you have used a microphone in your daily life. Chemical sensors can help to detect toxic gas. Image sensor are there in cameras. Biosensor, we use it in our fingerprint readers. And the gyroscope is the device which makes mobile phone games possible. So basically, we have different types of sensors. The next question is, how can we build a sensor? Resistive sensors are the most commonly used sensors because of their low cost. How does it work? Basically, the resistance of the resistive sensors will change according to the environment. For example, whenever the temperature, the light, or the moisture changes, the resistance of the resistive sensors will change. By measuring the change of the resistance, we will be able to measure the change of the physical condition around the sensor. Thermistor is a type of a resistor sensor or resistive sensor that is widely utilized to measure temperature. It is a semiconducting class sensor, and the temperature and resistance follow a logarithm relation. Basically, whenever the temperature increases, the resistance of the thermistor will decrease. It is a logarithm type of relation which is somehow complicated. However, if we focus on a small range of temperature, we can simplify the relation and approximate it by a linear relationship. Once we know the relation between the resistance and the temperature, we will be able to detect the change of the temperature by detecting the change of the resistance. Then how can we detect the resistance? Now, let's look at this circuit. This is what we call a voltage divider. We have a battery providing power to two resistors connected in series, RS and RL. Now, what is the voltage drop across the resistance RL? Because the two resistors are connected in series, we know the total resistance will be RS plus RL. Based on Ohm's law, we can calculate the current going through the circuit to be I equals V divided by R, which equals V divided by RS plus RL. And then we can calculate the voltage drop across the resistor RL to be Vn equals to I times RL, which equals to RL divided by RS plus RL times V. So basically, the resistors in series will partition the voltage according to the ratio of their resistance. Then what will happen if we replace RS by a thermistor? So what happens is, whenever the temperature changes, the resistance RS will change. And then the voltage across the resistance RL will also change. So by measuring the change of the voltages, we can measure the change of the resistance, and then we can measure the temperature.
Hi everyone. In this video, I'm going to demonstrate the working of a temperature sensor circuit. Does anyone of you know how a temperature sensor looks like? Well, if you look over this side, this little black blob here is the temperature sensor. It is in fact just a resistor, but the big difference with it is that its resistance changes based on the surrounding temperature. This particular sensor has an inverse relationship with temperature, so when the temperature goes up, its resistance will go down. To get a temperature reading from it, we need to make a little circuit and use the Arduino here to process the information. As we all know, resistance cannot be measured directly, and this is why we need to use this voltage divider circuit. As you can see, these two resistors are connected in series with a power supply coming out from the red pins here, going up and then through this resistor to the temperature sensor and then back to the ground. So if we take a voltage measurement here at this node, then we can measure the voltage difference. From a known supply voltage and resistance of a reference resistor here, we can work out the resistance of the temperature sensor and in turn the temperature using the equation. With this setup, we have a 10 kilo ohm resistor here and a 10 kilo ohm temperature sensor. At 25 degrees, it has a resistance at around 10 kilo ohms. To read the voltage output of the node here, we need to use the Arduino's analog read pin. They're over here. These pins are denoted with letter A before the numbers. When you set the Arduino to read from, for example, this pin, it detects the voltage and returns a 10-bit value that needs to be processed. So now I'll just connect this part to this pin here, to the A7, and then we'll set the Arduino to detect the voltage changes of this pin. And now let's take a look of the sketch and see how it's done. Okay, so here's the sketch. Before the main program, we have these values here. This first one is the constant value to identify the pin we're using, which we mentioned earlier was A7. So we assign A7 to the sensor. And then these values are for the purpose of converting the 10 bits value that the Arduino gives us and then convert it to temperature. In the setup part, we have the serial.begin 19600. This is only for the serial output, so we can look at the values from the serial monitor. The main program is this part here. So the first line we see here, that's analog read. So we set the analog read function to read pin 7, which is represented by a sensor. We assign it to sensor value. And then once we got this 10-bit value, we need to convert it to the voltage, the actual voltage. So here's the conversion. And then once we got the voltage, we need to convert it to resistance. And then finally, with the resistance, we can work out the temperature using an equation. And then we can print it out to the serial monitor using this code here. I gave it a delay of 1 second, so the temperature will refresh itself every 10 seconds. Okay, now I'm going to connect the laptop to the Arduino. And load the program. Let me check. Here we go, it's working. And as you can see, there's a light flashing here. That means it's sending our serial signal to the computer. So, whoops. If I open the serial monitor, we should see some readings. And yeah, there it is. Okay, so now it's indicating the temperature at around 22 degrees Celsius. So if I put my finger on the sensor, okay, so it immediately jumps up. Seems to be quite accurate. Yeah, the room temperature here is about 22 degrees. Obviously we can't get a 100% accurate reading because you don't know the actual resistance of these two resistors. So if you want to get an accurate reading, you need to measure the actual resistance and then make adjustment in your code. Right. I'm sure all these sound really complicated to you, but there's actually a simpler way to do it, which is using linear approximation. Obviously there's a drawback because if you're using that method, you know, the accuracy of the range is much smaller, the window is much smaller. So, but you know, it's useful for something like triggering the air conditioning or something, which only works in a small temperature range. And I'm going to show you how it's done here. And so first of all, I'm going to disconnect the Arduino. And I need to swap these two pins here. Anybody knows why? So now the voltage divider circuit is reversed. So the current is going through the temperature sensor first and then into the resistor. Okay, so the reason we changed the orientation of the circuit is because now we want the output of this node here to goes up when the temperature goes up. In the last circuit, it was the reverse. Anybody wonders why? Okay, I'm gonna change the code slightly here. I'm gonna comment out this line and this line here. Okay, so now we convert voltage to temperature directly without converting voltage to resistance. So we don't need this. And let's see what we've got. Whoops, forgot to plug it in. Okay, now it's working, and surprisingly, if you look at that, is pretty close. If I put my finger here, now the temperature is going up again. So as you can see, there's always more than one approach to a problem. I hope you enjoyed this little demonstration and learned something from it. Thank you and goodbye.